First off, good morning. Thank you everyone for joining today. I'm happy to see so many people trickling into the room. I really appreciate everybody being flexible, adapting to the online presentation, since the normal meeting room was needed for the candidate interviews. Dr. Burris, thank you very much for the introduction. Appreciate that. And I am aware of there being other imposter Michael Cooks in the university. I've gotten a few misdirected emails, and I've had some sent to me that never arrived. So with that, I am excited today to present on what I'm doing in my research in my master's program, some of the findings I've found so far, and to answer questions people may have on this. I hope everyone enjoys the talk, finds it informative, enjoyable. So with that, I can tell you why I can truly say my job stinks, but I don't mind it. So first off, I just want to give a big thank you to my committee, Dr. Marshall McDaniel, Dr. Sateri Sarkantoulis, and Dr. Dan Anderson. Thank you, all three of you, for the work, the support, and the patience in helping me learn how to do science. So the big question is, why would I bother working with manure? Why are we looking at manure as fertilizer when we have other options? We have synthetic fertilizer options available. So I would start with just saying, since the dawn of the Neolithic Revolution, when agriculture first became a thing, up until the mid 20th century, manure was really it. There were a few other options you could go to, but manure was definitely the big heavy hitter for providing fertility to your fields. In the mid 20th century, shortly after World War II, of course, there was the post-war chemical boom. Synthetic fertilizer is far, far more common now. Synthetic ammonia is the second most produced chemical globally. And with the agriculture up until that point, animals and crops were deeply integrated on the farms. The manure was feeding the soil and the crops, and then the crops were feeding the animals and the human populations. That 20th century chemical industry expansion, coupled with the mentality of growth, which was exemplified by Secretary of Agriculture Earl Butz and his get big or get out kind of mentality, led to what I would call siloification of agriculture, with farm operations becoming more and more specialized. And we see that today in that livestock are increasingly removed from the farm, and CAFO operations become more and more of the norm, that vertical integration, as it were. Despite the specialization, demand for animal products and animal meat is increasing. Manure is, of course, therefore still being produced, and at even higher numbers, but the sites of production are much more concentrated than prior to the industrialization of fertility. As of 2020, just approximately 8% or slightly less of United States cropland is fertilized with manure. In Iowa, that number is approximately 17%. Here is a really great figure I like that just shows that nitrogen synthetic fertilizer usage increase throughout the second half of the 20th century into the 21st. And this is just for the US. This figure is from Our World in Data. It's a really great resource that has a whole lot of information. So I hope a lot of you can find use out of this site. Really good stuff. But it really shows the incredible increase in synthetic fertilizer usage from the second half of the 20th century to present. Just in that first decade, 1960 and 1970, more than doubles. Worldwide, looking at this, there's approximately 70 billion animals raised for food annually. So even though agriculture has moved towards specialization, with disintegration of animals and crop production becoming the norm, animal production overall has not only continued but increased drastically. This is going to be true and continue, especially as developing nations progress and gain wealth. Their demand for animal protein and animal products increases as well. And as I mentioned, 70 billion animals raised every year globally for food. In the US alone, this is going to amount to about 1.4 billion tons of manure. 50 million tons of that manure is found in Iowa, between pigs, cattle, and poultry. This doesn't include specialty animals, pheasants and quail and things like that. This would be more like your chickens and turkeys. 50 million tons may seem like a lot, but when you factor in the fact that it only fertilizes about 17% of Iowa's cropland. So there's definitely room for more potentially. With the global demand for animal protein increasing, the increase in animals and more manure, we can look at this a couple of ways. We can see the manure that these animals are producing as a nutrient-rich resource, a valuable addition to our farmlands that can increase the fertility and the organic matter, or we can look at it as a waste material, a problem that we have to deal with. So I see it as a matter of perspective. So are we going to see this as garbage or a value? Gene Logsdon is a personal favorite author of mine. He has a book on managing manure, and this quote I was reading really stuck with me. And in it, he's referring to the Haber-Bosch process and the fact that synthetic nitrogen and the Haber-Bosch process that creates it is responsible for about 2/3 of the global population being fed. So were we in a room together, you could look to your right and you can look to your left, and if it weren't for Haber-Bosch, those two people wouldn't be here. That said, it is dependent on non-renewable energy sources, creating this fertilizer to grow our crops. Using natural gas to create ammonia for fertilizer is a one-way path. It's burning precious fossil fuels, contributing to greenhouse gas emissions, and a large amount of the crops that we grow with that fertilizer are used to feed those animals that we raise for food. These animals produce manure, which is a valuable source of fertility, as I was contesting, and that could save at least some of the synthetic nitrogen needed in the first place. So by adopting a viewpoint similar to that which Logsdon is advocating here in this text, we can begin to close the loop on our fertilization of crops and get a step closer to sustainability. But again, I really like how bluntly he puts this here as just sources of chemical fertilizers decline. We're either going to see manure as once more a pot of gold at the end of a rainbow, or our population levels are dramatically going to decline. It's an either or. That said, it's not that we just need to apply manure and all of our issues regarding synthetic fertilizer and chemicals and fossil fuels and greenhouse gas emissions, that's not just all going to go away. Manure is inherently variable in its nutrient content, and even when it's sourced from practically identical animals in the same operation that are being fed the same diet, there's going to be variability. We can't control that 100%. The soil itself is also going to play a role. Soil chemistry, soil physics plays into how that manure behaves when it's applied to the fields. When we factor in the vast number of animal production operations across the globe and the differing diets that they are fed, it becomes even more difficult to predict that nutrient availability, both quantitatively and temporally. Add in those soil factors like pH, and it gets even more convoluted. So what I'm doing here with my master's program, the reason I study this is, can we predict this? Can we get a better understanding of how the nitrogen mineralizes, how it becomes plant available, and make manure a more attractive solution, give it broader applications? So the objectives of the research that I'm conducting are broadly to help solve these troubles using manure as a fertilizer, laid out on that previous slide. More narrowly focused to answer these objectives that I'm laying out here. The first is just quantifying the soil nitrogen dynamics temporally over a couple of years in the field, and also determine mineralization patterns quantitatively and temporal with different manures and different rates in laboratory settings. So as I kind of hinted there, in an effort to do this, my research is divided into two broad categories of field work and laboratory work. The field work is further subdivided, which I'll touch on here. So the first part of my research is the field, and that's the first segment of that is at the Layers field, which is west of Ames, just off of 30 near the main research farm. Layers stands for Land Management for Improved Yields, Environmental Resilience, and Sustainability. You got to love a good acronym. It's 27.5 or I'm sorry, 27 1/4 plots, quarter acre plots that were designed and installed in 2021. So it's a relatively new site. These plots operate under a corn and soy rotation, and here you can see an overview of that. I'll come back to that here in just a second. Under that corn soy rotation, there are 5 treatments or 5 factors for the treatment. There's manure fertilized, which at this field, as may be indicated with the logo here, it is poultry manure. Or UAN is used for the fertilizer, or it's a mixture of poultry manure and UAN. And then it's also divided into cover crop and no cover crop using cereal rye. The fertilizer is only going to be applied in the maize years, in the corn years. My work at Layers consisted of sampling the soil 2 times before planting, and then once monthly throughout the growing season. And then I would sample the soil 2 more times post-harvest, once immediately after harvest, and then once after the fall manure application. The soils were collected to a 30-centimeter depth during soybean years because it wasn't fertilized that year, and 60 centimeters during the maize years. I pulled 4 cores from each plot, and then the cores are mixed and composite samples used. Those soils were sieved through an 8mm and then a 2mm sieve, and then a subsample of that 2mm sieve soil for each plot was extracted using 2 molar potassium chloride, and then used a colorimetric microplate reader and reagents to analyze for nitrate and ammonium content. Those results were then I plotted onto a time series graph that helped visualize the inorganic nitrogen patterns throughout the season. So again, just showing the field overview here. You can, I'm not sure how clear it is for you on your computers. Hopefully it's fairly clear. Showing just those different treatment systems. So cover crop, no cover crop, is it UAN fertilized, winter manure, spring manure, or the balanced system? And you can see those 27 plots. Some of you in attendance today have maybe been out at the field with me and helped me collect soil cores, so I appreciate that. You know this field fairly well. Here's just a photo in the corn 2 years ago when I was collecting soil samples. And then here's last year during soybean. And one of our dedicated undergrad laboratory workers helping collect soil samples later in the season in the soybeans with me. As mentioned, soybean was just to 30 centimeters. During the corn, we would go to 60 centimeters. Here's a photo of just showing kind of the process where I would do the colorimetric, do the extraction with the KCl into these little scintillation vials, which would then be used to take an aliquot and put those into the colorimetric microplate reader with the reagent to get those nitrate and ammonium levels. All that said, this is some of the results we had there. So the arrow here on the far left pointing down indicates the timing of the application for the UAN. The fall manure and the spring manure as well would have been applied at that time. The fall manure was applied post-harvest in the previous fall, 2021, about mid-November. But the graph just doesn't go back far enough to include that arrow here. But we can see this is kilograms of nitrate per hectare throughout that 2022 season. We could see shortly after that UAN application, a big jump up and then a slow trickle down as the plants used it throughout the season. The next year, because it didn't receive fertilizer, still some mineralization happening, but nowhere near that initial jump. And then here is the same graph, but for ammonium. So kilograms of ammonium per hectare throughout that same time period. Again, same rules apply. The UAN and the spring manure were applied where this arrow indicates on the left. The fall manure was the previous year during the fall 2021, shortly after harvest, mid-November. Interesting results here. We see that after that UAN, really not a lot of ammonium compared to the nitrate levels, but then a big jump up in ammonium the next year during the soybean season. So that was the first part or the first tier of the field research. The second part was working with commercial growers at other fields. So in collaboration with Iowa Soybean Association, 15 commercial growers that were utilizing hog manure. So the Layers field, just again, a distinction I find interesting is the Layers field data is all poultry manure. The commercial growers are hog. And or UAN on their fields. that sampled in season. These soils analyzed very similarly for nitrogen mineralization. The data is analyzed similar to what I did for layers in that I'm creating a time series of nitrogen mineralization throughout that growing season. The 15 growers were meant to cover different areas of the state that try to represent the differing geographies of Iowa. And again, just ultimately what we're looking to create is that time series analysis to show the differences between manure, synthetic fertilizer, or combined. So here's some of the results from one farmer. These are preliminary results, so I don't have everything finalized for all the farmers, but I did pick a couple to show with you today. So this is, I just named him grower number 7. He was the 7th field in the panel, showing the difference between the yellow being without manure and the pink being manure fertilization, and just those ranges that you see in nitrogen mineralization for nitrate kilograms per hectare, similar to the layers field. And here's grower number 12. Again, same thing, just a different grower. So manure versus no manure fertilization, kilograms of nitrate per hectare throughout that growing season. This is 2023. The previous one is 2021 into 2022. So that is the field research aspect of it. The second, or I guess third tier in this case, is my laboratory research. So what I did here is a controlled incubation. I like this. It's a controlled environment. It allows me to test multiple manure types and the different rates of application. So in order to gain an applicable understanding of mineralization rates of those manures and soils, we do this incubation using 3 different manures. I've got swine, beef pack cattle manure, and turkey litter that I've applied to 2 different soils. There's a Sparta, which is a sandier soil, and then a Clarion, which is a clay loam. And I applied those manures at 2 different rates, a low and a high application rate. And that's based on the standard manure application rates for Iowa. It's a little subjective. You kind of have to play with it, but it's pretty accurate as far as what would be considered a normal application rate. And then I went low and high on that. The manure was analyzed prior to the incubation for all nutrients plus carbon. So I'm going to go through these fairly quickly because I don't think anybody wants to thoroughly read a manure analysis report, but swine, turkey, and beef. And the key thing to look at here, I think that's interesting, is the estimated first year availability pounds per 1,000 gallons or pounds per ton. So you can see the swine is drastically higher at 42 pounds per 1,000 gallons versus on the turkey, 2 pounds per ton, and the cattle at 1 pound per ton on the ammonium nitrogen. So with that, the incubation, I'll call it incubation number 1. I used 50 milliliter centrifuge tubes with the 4 treatments. So the 3 manures at the different rates plus a control with just soils with 9 time points, and I did 4 reps of each treatment. The initial incubation experiment ran for 91 days. The first extraction showed a slight uptick in nitrate levels, but the rest showed virtually flat results for the rest of the time. So I won't say it failed, but I found a way that didn't work. After several discussions with my advisors, lab colleagues, and other peers in the department, I'm still not 100% certain, but I'm pretty sure the most likely reason what happened is that the soils dried out. The lids on the centrifuge tubes were not secured entirely tightly, and I removed them once a week to aerate the samples, but I think they just dried out too much and the mineralization stopped. So with that, we've made a decision to try it again. And we're going to do a second round of incubation. Here's that result I was talking about where it's virtually flat. So not what you would expect to see for a nitrification or mineralization experiment. So for the second round, I doubled the soil, lowered the water holding capacity to 50% from 60, using the same time points, the same manure treatments, plus a control, but I am tripling the amount of manure as well. And we're moving from the 50 milliliter centrifuge tubes to 125 milliliter Nalgene bottles, 10 grams of soil instead of 5, and 3 times the manure rate. And so we'll be doubling the extraction fluid as well for 50 milliliters of KCl. But same treatment as far as we're going to extract them, take an aliquot, use the reagent to develop those colorimetrically and analyze with the microplate reader. Went a little too far there. So that's where we stand at this moment. So I would like to say, just again, a huge thank you for all the help I've received from my lab mates, my coworkers, my advisors, for all the different points of my research, working in the field to helping me weigh manure into bottles. I know that's not a very glamorous task. So again, really big thank you to everybody from the Arcantulus and the McDaniel labs and everybody's help on that. So with that, thank you all very much for listening to my manure story. And at this point, I will take questions that you might have.
Well, first, even though we're all online, let's thank Michael. Nice job, Michael. That was fun. And so, yes, and like that. And so questions. It's not like manure is a straightforward topic. So, Michael, I applaud you for a ambitious, challenging project. I remember years ago, Fred Blackmore was here. He had PhD student after PhD student who just confused me with what they were doing. So I really appreciate what you're doing. But anyway, questions for Michael on manure and mineralization, either in the field or in the lab.
For what it's worth, Dr. Burrs, I get confused all the time too. So it's
no. I'm it's a fun stuff.
Yeah.
So this isn't a question about your actual research, but it has to do with your introduction.
Mhm.
You mentioned there were 70 billion animals worldwide, livestock. I assume that does not include fish, right?
Right. That's talking just, I guess, land livestock.
Sure. Yeah.
So your standard, cattle, poultry, pigs, sheep, goats, rabbits, I would assume are included in there as well. Any meat animal.
Major livestock. Yeah.
Yeah.
Yep. And then my other question, while people are thinking about how to ask questions, this has to do with your lab study itself. So when you're doing your incubation and such, what temperature are you doing it at?
It's just in the lab room itself, which is about 70, 72 degrees.
Yeah, 23 Celsius or something like that. So
Right.
yeah, so I was just wondering, have you thought about varying the temperature or anything to see if you can kick it a little bit that way?
Yeah, absolutely. So one of the initial discussions we had looked at when we were setting the parameters for the incubation, how to go about this, the number of manures, the treatments, et cetera. We had discussed doing a hot and a cold, or a hot and a room temp.
Right.
For now, we've just settled on the one temperature. But
Right.
as Marshall and Soterios have mentioned a few times, there's a PhD or two's worth of work here.
No, right.
So there are a lot of I've honestly gotten really into it as far as thinking about, here are some other variable methods we could approach on this. Like you said, doing a different temperature, going hotter or even colder, testing not quite freezing. And I know the results wouldn't be super staggering or surprising, but doing that, what would mimic kind of a winter, where you have, really low temperatures, maybe like a week of frozen, and then bring it back to just above freezing and see how that plays out over a simulated winter.
Right. And I ask it in part because I think temperature variability, from a microbiology point of view, the warm, moist with a lot of oxygen, so to speak, should help. It depends on exactly which reaction you're interested in. But at the same time, I think from a practical point of view, variability over a season, you have periods of stimulation and periods of where it's just inorganic reactions occurring. So I think that changes how it works. But no, you have plenty of work. I'm not trying to generate more work.
I appreciate that.
Rather the opposite.
No, there's a lot more that could be done on this, and there's years of altering things and just playing around with the situation to see what happens. So I agree with you. It'd be very interesting to see. I do see Dr. Thompson put a couple of questions in the chat. So
I'm glad you go for it. Yes.
Yeah. So the soil properties at the field site, the layers that I've worked at and the growers' sites do vary because they are at different points in the state. So some are more your clay loams, a few are more sandy soils. I don't have the information in front of me as far as what specific soil series is where. But that absolutely does play a factor into it, and it would be something that would have to be considered in the analysis and discussion of the data is what would happen. And that's part of the reason why we have the 15 different growers spread across the state is we're doing similar treatments. It might not be exactly the same, pretty similar treatments as far as swine manure, UAN, both at this type of soil at this part of the state and doing the same or similar treatments at another part of the state. So when I go to analyze the actual data, I'll have those field maps and I can compare and factor that in, certainly. As far as the nitrogen application rate for the incubation study, that was calculated, it's based on the carbon content of, it was pegged to the carbon content of the cattle manure to try and mitigate the effect of the swine and the cattle being solid or at least semi-solid and the swine is liquid. So trying to make sure that they got a similar amount applied. But yeah, it comes out to pounds per acre reduced down to the 10 grams of soil. The new application is going to be similar there. It's just tripled from the original application rates to get more manure, try and get that reaction to show higher values than what I initially showed with that lower slide. I haven't taken into account like the fixed ammonium in the soils, and I do have the soil data, just not at hand right now, so I don't know the clay concentration off the top of my head. And as far as the depths of the concentration at different depths, again, I do have those numbers. I just don't have them on hand in the slideshow right now. But this is something I'd absolutely be happy to get these numbers together and further discuss later. And Dr. Thompson, I see you have your hand up on the icon there.
Yeah, so thank you. I just want to follow up on one response about the application rates. You said
Yes.
that you wanted to even them out for the different kinds of manure.
Right.
Which makes a lot of sense. But then what was the rate in terms of pounds of nitrogen per acre or kilograms per hectare or whatever?
If you give me a moment here, I will switch out my thumb drive to my external hard drive, and I'll pull up the calculation spreadsheet I have for that, so I can give you an actual
You don't
number.
have to do that. You don't have to do that, Michael. But sometime let's get together and talk about it.
Absolutely, yeah. I have those numbers as far as what it equates to for. It comes down. It's milligrams that I'm actually applying, but when you scale it up, yeah, it comes out to like a pound per acre number because I'm only doing 10 grams of soil in the incubation. Yeah. So it's the application rate's like milligrams of manure.
Yeah.
So you may see a question, Michael, that Derek Plateau has asked a question too about nitrogen inhibitors as a way to reduce nitrous oxides or N2O emissions from manured soils. Any insights on that?
I personally don't have a lot of experience with them. I know of them, and I'm certainly intrigued and in favor of studying like the saturated buffers and things like that to mitigate nitrate runoff from the field. This is part of why at the Layers field and some of the commercial growers do use cover crop as a means to keep some living roots there at that early season and late season point when there aren't crops on the ground to hold some of that nitrate instead of being washed off with winter rain, snow, slush mix, or those early spring rains before we get crops in the field. So yeah, I'm certainly in favor of experimenting with that. Like I said, there's so many different parameters and aspects we can look at this study and continue doing multiple field and laboratory studies to really get a handle on this. And I mean, that's part of why I like this is because it's limitless work. So it's job security in a way, because I've always got something fascinating to look at and say, well, what if we did this? So short answer is, yeah, I'd absolutely be interested in investigating the impact of using nitrification inhibitors or using those bioreactor or saturated buffer strips on fields to see what the impact is from, especially like right after a manure application if we got a heavy rain. Yeah. And Dr. Horton, I see you put a question in regarding The Logston quote, so rather than a dramatic reduction in population, could it be a dramatic change in diet towards plant-based? Certainly an option. I'm not negating that would be probably a good way to go about things, is maybe not eating so many pounds of meat every year. It's a tough sell, not only here, but especially in developing nations where this is relatively new for them. And we've had this, 50, 60 years of relative ease of go to the supermarket and buy as much meat as you really want, whereas this might not be the norm for them. And it's that whole question of, well, why don't they get a chance at it kind of thing. So I would agree with you. It's everyone would do better if we ate some more vegetables and fruits. But I just think it's a bit of a tough sell. But certainly something to investigate. And I think there are efficiencies in how we produce livestock as well that could be examined. And then I see there was a question, Yemi asked about why use turkey litter for the experiment. It is lower to some animals in Iowa, as far as, we probably have more layer chickens. And that's what's being used at the layers field, is layer chicken litter. The turkey litter was decided upon when I spoke with Dr. Anderson, Dr. McDaniel, and Dr. Arkantulis. We were determining what manures to use, what was available, what we could easily get and analyze. And it's not the most popular animal in the state, but there are a pretty good number of turkey operations. And so it's not something to negate because it's not the biggest, so don't use it. It's definitely used, and it's worth investigating. And again, for one of those further studies, I'd be interested in looking at side-by-side field and laboratory. What's the impact on turkey litter? What's the impact with layer chicken litter? And what's the impact with broiler chicken litter? So again, these questions come up of there's so many comparisons and data to look at. So I think the turkey litter is worth looking at, even though they might not be the largest population of poultry in Iowa.
Well, excellent. Wonderful seminar. So let's thank Michael again, and he's around the building. So when you're wandering around, let's say hi to him and congratulate him and ask him more questions. But thank you, Michael. Great job.
Absolutely. Thank you all very much for coming today. I really appreciate it, and have a great rest of your day.
Thank you. And next week for Soil Science Seminar, we'll have Johnson Matama. But with that, I'll see you all in 167 hours and like 25 minutes. Thank you very much. Bye-bye.
Thank you.